Cool. Thank you.
Thank you very much. All right. Hey, we're starting a minute late here, so let's get right to it. Yes, my talk is SBOMs for evil, and subtitle of Turning an Unremediated Software Supply Chain Documentation into an Attack Path. Lots of fun putting this together. I spent a lot of my career thinking about how folks can use data in different ways and thinking critically about how that data can be used for bad stuff and ultimately good. I had a gentleman that I'm acquainted with the industry that I respect very much, Mr. Alan Friedman, call my boss on Tuesday, and Alan works for Department of Commerce, and Alan is like one of the biggest advocates for software bill of materials, and I love Alan and I love the work that he does. And he called my boss and told my boss, "What is your guy doing? This is not helpful." I assure you that it is helpful, and I hope Alan gets the chance to watch this talk and isn't mad at me anymore, because I really think we're trying to do a good thing here with the concept of software bill of materials for evil. So let's make Alan proud. All right, so a little bit about me. I'm the Product Security Research and Analysis Director for Finite State. I'm arguably a reformed penetration tester. I spent roughly 20 years doing penetration testing for internal teams and 15 or so years for consulting as well. I'm the co-host of Paul's Security Weekly, one of the early security podcasts, and we're in our 19th year. Yeah. The podcast is older than Paul's marriage. Okay. And he's been married 18 years. So, yeah, it's not older than mine, but it's close. I have a bunch of SANS certifications. I'm a principal instructor at SANS and an author for the 617 wireless class and SEC 556, which is a 3-day IoT hacking class. And that's sort of where SBOMs come in for me, is talking about all of this hardware stuff. And I also joke, as part of that authorship stuff, I'm a recent convert to the Oxford comma. Commas save lives, folks, right? Another little fun one here. This is me, but this is the AI representation of me. I'm told that this one makes me look like a fat Steven Seagal. All right. I'll take it. I mean, I've been called worse. I've been called better. But every image in this presentation has been generated by AI. So I'm fascinated by AI. Sorry. Every non-screenshot has been generated by AI. There's a couple of screenshots in here that were not created by AI. So my headshot has been created by AI. A couple of ones will actually see that I've fed this AI-generated headshot back to AI to have it generate some different stuff. So multiple iterations. How many layers does Inception go deep? At least 2 in this particular presentation. All right, so let's set the stage for talking about software bill of materials for evil. Let's set the stage about what an SBOM is and how do we get there. So in order to understand about our SBOMs and where we start to get them from, we need to understand where the code in our devices and or our applications come from. Okay. If we start taking the context of, say, an IoT device or an ICS device, or potentially even your traditional Windows desktop, you're going to have code that is either third-party or first-party. The third-party code is the stuff that is being given to you by your supplier. Let's say Windows, or your operating system, or some drivers for some of the components in your IoT device, or maybe the web application that controls your management for your home router. That's all third-party code provided to you by someone else, and is typically delivered to you in some binary format that you typically don't have access to the code for. The first-party code is maybe something that you or writing, or you're getting from something open source, or something that your company has written to put on top of this device. Some additional features for, say, an IoT device that is a door lock. Maybe you get something generic for the operating system for the door lock, and then you write the code that actually operates the door lock and does its authentication and so forth. So that is the stuff that you have done. And this is the second iteration of me. So this is the, hey, it's the first Birdie code, so it's familiar, it's written by me, but is it really? So now that we have the code, we need to do some analysis of that code to start understand what makes up that information, that binary. And we sort of have two concepts here of shifting left and shifting right. Traditional source code analysis, or SCA, is shifting left. That is doing the analysis of our source code at the time of use or within our CI/CD pipeline, so that every time we do a build, we're doing that analysis of the components and we're coming up with that list. On the other hand, doing the analysis after the fact, after everything is built and we're providing a binary to, say, our customers, that's where the binary analysis happens. And maybe we're only doing that on the final release that we put on the binary that we put on our website for, say, router firmware that you download. Okay. The source code analysis is going to get, the SCA is going to get all of your stuff because you have direct access to the source code. But arguably that only represents about 20% of a completed binary product. Okay. The binary analysis, shifting right after everything is complete, can get up to 100% of all of the contents for your binary, for all of the various components. Okay. But it's a lot harder to do. All right. This is the only AI-generated image that I could actually come up with that could get the text the way I wanted it. Yeah, text is really hard, even with the V6 of Midjourney. And arguably, it wasn't quite what I wanted, but it was close enough. So this is going to be the only sort of transition that it's actually in the image. I do have some other text later on in the presentation, and when I put it in, and our marketing folks looked at it, and they said, was this supposed to be misspelled? And I'm like, no, AI did it. So I changed it for one that's actually spelled correctly. All right, so what is this? What is an SBOM, or software bill of materials? It's arguably a great corollary to a software ingredients list. You know, when you buy food in the grocery store, it gives you that list of all the dietary requirements and where it meets, and it gives you an ingredients list. An SBOM is effectively that, is an ingredients list for your software, whether that came out of SCA or some binary analysis. It's everything that went into building that binary and or building that software. Okay. So great, that's cool. What makes up my software? How do I get one of these? Well, the joke in the industry is typically you're now calling up your manufacturers, you're trading email with one of your manufacturers or someone you use their software and asking for one. They're typically not freely distributed. Some are, but most of them aren't. And the joke is that, oh yeah, you can totally have one, I'll email it to you. So we have a really bad job right now of doing aggregation and distribution of software bill of materials. Once they're out there, they can be potentially redistributed. So once it's out there, it's out there. You know, we talked with Matt about once you put something on the internet, it's there, like archive.org. Similar types of things can happen here. But storage, coordination, and updating of those software bill of materials is currently something that the industry has a hard time dealing with. And there are a few companies that do that and do it well, but few and far between. Arguably, we could go generate our own from source code using SCA, using some of the free and open source tools, such as like the SPDX SBOM generator or the Cyclone DX CLI tool for generating SBOMs from open source code or other code bases that we have access to. Unfortunately, doing the binary analysis is significantly more difficult, and I know of no good open source tools for doing binary analysis to generate SBOMs, and in fact, I don't know of any good tools because I don't know of any tools. Unfortunately, all of the ones that I am aware of are commercial tools. So, but then again, I work for a company that does that commercially, so I get to cheat a little bit, right? All right, so with the SBOMs, we have effectively 3 different SBOM formats. SWID is one of the other ones, but we don't hear as much of that in the industry anymore. We are typically with CycloneDX and SPDX. Lots of data stored within those in a hierarchical fashion. And the real bonus here is when we start enhancing or providing additional data around the data sets of what went into that software package. What's in the SBOM? What ingredients are in our software? And that's really, in my opinion, where a lot of the value comes in. And we'll see some of just the plain ingredients list be helpful as well. Okay. And this is where the enhancements for our either CycloneDX or SPDX formatted SBOMs come into play with CVEs, CPEs for doing pattern matching, and VDR, or vulnerability disclosure reports. So if we have a list of components that made up some software, we know all the parts that went into it, or 20% or 100%, depending on how we did our analysis. We know the parts that went into it. Are there vulnerabilities in any of those parts? Sure. Which vulnerabilities? And that's really where CPEs come in, so that we can match those components to individual vulnerabilities and then see what those potential vulnerabilities or those issues were tied to a public CVE. Cool. Well, now we start getting some background about what we can do with some of that data. And the enhancement is lots of fun. I work for a company that does some of this type of enhancement. We'll talk about some of that more. But dependency track is one of those tools, free and open source, that you can use to take an SBOM and do some of that enhancement. It's absolutely worth every penny you pay for it. It's free and open source. But there's also some detractors to that. It's worth every penny you pay for it, right? So that's the double-edged sword about open source stuff. Okay. So that's good. The future of SBOMs, we're going to see more and more enhancement and enrichment of that data. Specifically, one that I'm particularly excited about when we start talking about SBOMs for evil is around vulnerability exploitability exchange, or VEX. Effectively, what VEX gives us the ability to do is that if we release an enhanced or an enriched SBOM to say, hey, this software component is tied to these CVEs, but our stuff isn't vulnerable because we've done an analysis and the functions that are linked to this CVE we never reference in our product. So you will never end up down that code path. So while we use these particular components, we use these ingredients, our product is not vulnerable. But someone has had to go and do some of that analysis to make that attestation. Okay. Speaking of attestation, I'm also excited to see some potential marrying of SBOMs and so forth with the SALSA framework. The SALSA framework for giving provenance to, yeah, hey, we generated an SBOM and we did this stuff, and we hashed this data and we hashed all of these individual things so that we're giving you an SBOM that is accurate and hasn't changed. So some fun stuff potentially with the future. So why do we care about software bill of materials? We talked about what they make up. We talked about this ingredients list. Why do we care, and why is this a thing? Well, from a couple of standards and things that have moved forward in our industry. Here in the US, the Food and Drug Administration, the FDA with 524B. If you have a new medical device that you are submitting to be used in the medical theater and to be used in humans, as part of their new submission process as of a couple months ago, they require the inclusion of a software bill of materials as part of the submission process. They're also doing a whole bunch of other stuff, including pen testing, vulnerability remediation, and having plans on how to remediate vulnerabilities. And SBOMs can start helping down those roads, especially when we start talking about VDR and VEX data. To help go that path for that vulnerability resolution. Okay. Also, the 2023 Omnibus Bill here in the U.S., effectively, if you want to start selling products into the U.S. government and or the military, you need to provide a software bill of materials, and those are some big markets, and there's lots of money there. Okay. So yeah, you need to have an SBOM for your product and your software if you're selling into the U.S. government and or the military. Now, it's not just U.S.-centric. The European Union Cyber Resilience Act, in an attempt to make all of the cyber products that EU citizens use, they are start asking for software bill of materials for doing that inventory so that you know what type of software you're ingesting and you can track that so that everyone can have better cyber hygiene, as it were. And yes, the next part does actually say blah, blah, blah on it. It's not there just as a placeholder. But I'd argue that you can also use software bill of materials in your organizations as an end user for some overall security hygiene. If you have a device and you have an SBOM for it, and you know that it has certain components, and oh my gosh, there are potentially some vulnerabilities here, you can now make some risk decisions about how you're going to structure your network, how you're going to do access control. Maybe we need to put all of these devices on a separate VLAN so that so-and-so can't get from here to there. Maybe we need to have some additional monitoring around compromise and so forth. Okay. Yet, I don't find that a lot of either red teams or blue teams are adopting the use of software bill of materials. But that's why I'm here. I'm hoping to change that for both good and bad. Okay. Mostly good, right? All right. So software bill of materials for good? Yeah, but Larry, you told me software bill of materials for evil. Yeah, but good too. One of my coworkers argued that actually might have been my desk in my office. They're not far off. Okay? Maybe I provided a picture of my desk to use as the initial seed for that. No, so not far off. All right, so software SBOMs are good. Yes, as a consumer of devices, they can provide you potentially a software bill of materials, which gives you an opportunity to evaluate how those companies are doing their security posture. How often are they updating libraries? Have they noted that they can be enhanced and that there are potentially some CVEs tied to them? And can they update some of that type of stuff? Like, you think about stuff that's been happening currently. What happened if Avanti had provided SBOMs for some of their stuff recently? Have you seen some of the Avanti stuff? They've been a big target for some of their VPN appliances. I saw an article yesterday that someone had done some analysis, and they were using an 8-year-old Linux kernel and some 20-year-old libraries that, like, there's vulnerabilities all over the place. And how can an enterprise get away with doing that and having that lack of due diligence? Like, to me, a software bill of materials for good as a consumer is an opportunity for me to really put some of my suppliers in check to see how they're doing for their due diligence. And make some other better risk-informed decisions about how we put these things into practice. Okay. So some other ones. The prime example here why I really fell in love with software bill of materials was Log4j. Okay. Log4j vulnerabilities come out remotely exploitable. Oh my gosh. But it's only in a couple of products, right? No, it's in everything. But do you know it? Do you know that everything in your network, in your enterprise, or in your home has been updated for the latest version of Log4j? Gentleman down the front is shaking his head yes, because he uses software bill of materials. No, because you had to do it. Yeah, but you know what would have been a huge help? If we had software bill of materials for everything on our network and we could go look them all up and go, oh, those devices have Log4j in it. Like, some of the manufacturers, when the Log4j came out, said, yeah, no, we're totally fine. We don't have Log4j. Oh, wait, we do. Yeah, they had to backpedal a little bit. But if they had had software bill of materials, we would have known what that ingredients list was so that we could have made some accurate risk decisions. On the converse, if you're a supplier and you are providing software bill of materials, do you think it's a really good idea to provide a software bill of materials that you can link to a bunch of CPEs, and a bunch of vulnerability data? Do you think you might want to spend some time updating your stuff? Yeah. Yeah, so this is, in my opinion, an opportunity for organizations to prove their commitment to security and their health of their software. Okay. So, yeah, can we use them for evil too? Okay, and this is where Alan hates me. So, I promise, Alan, you won't hate me that much. We may come to terms, but you know, I think he's going to be happy regardless. Okay, so software bill of materials for evil. Yeah. In the evil part, it really comes down to that enhancement and the enrichment and tying it to CVEs to match those ingredients, those individual components to some potential vulnerabilities. And then tempering that potentially with not only the CVE score, because that whole scoring system is a mess right now, with some tempering with stuff like exploitability, possibility with EPSS and so forth, to give us some priority as to what to look at. Not only from a defender's perspective, but from an attacker's perspective. Where should we potentially target? Okay. Also, because we have a list of CVEs and some potential areas to focus on based on some of that scoring, many of those CVEs have some exploits attached. And this is where some of the threat intelligence really comes into additional enhancement and enrichment. So not only is there a CVE, but is there a publicly available proof of concept? Is there exploit code available? Is it weaponized? Are there threat actors actually using this, and have we seen it in the wild? Yeah, that's incredibly helpful. As an attacker, as someone who spent 20 years as a pen tester, and thinking with that adversarial mindset, if I have an SBOM or I can generate an SBOM for a product and I can enrich that, I now have some potential attack paths and some targets, and I have yet to send a single packet to a network. And I may already have a path to compromise. Then, of course, what I do with that. But we have some things that we can do to help with some of that. All right, so arguably, I'm running quite fast here, so I might have time for a bunch of questions. And I'll have time for my demo. Okay, I didn't sacrifice enough to the demo gods this morning, so we'll see how it goes. All right, so let's take a look at the case study. A case study? Yeah, See what I did there? So I am gonna, next week when I get back to the office, I am gonna release all the prompts that I use to generate these images, just for fun, because I can and I'm fascinated by it. But yeah, this was very much a, we're talking about SBOMs for evil, so let's go into that electronic wasteland. And we've got this this traveler going through that wasteland, hauling a case behind him with all his exploits. Yeah, that was sort of where this was derived from. All right, so let's use OpenWrt for our case study here. A quote from the OpenWrt website. They're a project that is an open source Linux operating system to replace the firmware on your embedded devices. Instead of creating a single static firmware, it's very open, developer friendly, lots of configuration, lots of options, package manager, and so forth. And this is how they describe themselves. Now, the big thing that I want to get across here is that I love OpenWrt. I mean, 15 years ago, my good buddy Paul and I from Paul Security Weekly, maybe even more than 15 years ago, I lose track of time, we wrote a book effectively about using OpenWrt for your Linksys router. Like, it's been around for a long time. I love OpenWrt, and I want to stress that it has been my experience that when there are issues and there are security problems with OpenWrt, they are very quick to respond and they do their due diligence. So this is, we're using OpenWrt as a case study, but it is not an attempt to undermine OpenWrt in any stretch of the imagination, because they do a really good job, and I'm very proud of what they do. But they just happen to be a ready target, specifically when we talk about a lot of consumer IoT type of devices. Because it's free and open source software, you see a lot of manufacturers adopt OpenWrt as their base operating system and then build their IoT device on top of it. And I'm maybe even getting a little bit of ahead of myself here. So for OpenWrt, with that open source firmware, we now can tinker, and other folks can tinker, and we can develop custom stuff. We have our own package management system. We can create new packages. It's Linux under the hood, so we can, do all sorts of Python and Perl. Like, wait, we can do Python because nobody does Perl anymore, do they? I mean, there are people in the industry older than I am that do Perl. Okay, yeah. There are still some folks that do Perl. It's okay, we can still be friends. I'm not a Perl guy. Okay? I'd argue I'm not a Python guy either. I'm a Bash guy. Okay, so, all right. The one thing that is fascinating about OpenWrt is it's free and it's open, and their licensing does allow you to use it for commercial purposes. If you make any changes to any of the stuff that OpenWrt has provided, you're supposed to release those changes back to the community. And this is where Linksys got in trouble many, many years ago, and part of the reason why we have OpenWrt nowadays was because of that movement. Okay. So when they allow commercial use, I see time and time again that there is some commercial device in the IoT, consumer IoT space that instead of spending hundreds of thousands of dollars or thousands of development hours putting together an operating system and a bunch of utilities for their device, well, there's this one free off of the shelf that we can use, and it ends up not just in Larry hacking on some device because he wants to turn his router that didn't have a VPN into a VPN concentrator. It ends up on potentially millions of devices under the hood as third-party code. Okay, so stuff that you don't necessarily know about. And you're saying to me, Larry, well, that's great. Why do I care about all of these IoT devices and OpenWrt? Well, because COVID changed everything. Okay. Well, how do you mean COVID changed everything? If you think about enterprise assets in the companies in which you work, in early 2020, everybody worked from home. You took your enterprise asset that under most normal days lived on an enterprise network with all sorts of enterprise security, and the enterprise controlled what went on that network and had VLANing and all sorts of other fun stuff to control what was on those networks. And the enterprise said, hey, take your laptop home and go work from home. And you plopped it on your home network. And, well, you know what they say about the cobbler's kid's shoes? Like, this is one of the things that my mom always told me. Cobbler's kid's shoes are always the worst, right? Why? Because the last thing the cobbler wants to do when they get home is fix more damn shoes, right? I'm a security professional. What do you think my home network looks like? The last thing I want to do when I get out of work is fix my damn shoes, right? Yeah, no, it's not that bad. Do stuff, but arguably there are lots of things that I could do better. And I'm the guy that has a clue, I'd argue, and knows better. But think about how many other people in your enterprise organizations that have no clue about their IT security and what IoT devices they're putting on their network. And do they VLAN their IoT devices from the rest of the stuff? What's a VLAN, right? Yeah. So COVID changed everything. You take your nice, secure enterprise network and you shift it out to somebody's house where it's the Wild West, and potentially with all sorts of fun OpenWrt stuff. And if it ain't broke, don't fix it. Yeah, we're going to do some examples here with an older version of OpenWrt that has been fixed, it's been patched, but I'm just as bad as some of the other folks. Like, every time I go into my home cameras, I use Wise. Every time I go to look at something on one of the camera, it pops up and says, hey, there's an update for this camera. Would you like to do the update? No, I actually want to see what's going on the camera. Cancel. And then I forget about it. And like 2 days later, I want to go see what's on the camera. Oh, did UPS show up and drop those packages on the front porch? Hey, there's an update for your camera. Do you want an update? No, I want to see it. Do you know how long some of my cameras have been out of date for? Longer than I'd care to admit. Yeah, I actually went through the other day because I was coming here to complain about I never update my stuff because I need to use it. Same thing. How many of your enterprise users that are working from home on their home networks update their stuff? Well, my router, my Linksys router, my Wi-Fi access point, it just works. And if I go to update it, it takes it down. and my kids are doing homework from their Chromebooks, and my significant other is streaming something on one of the streaming services to the TV, and if the Wi-Fi network goes down to update that Wi-Fi router, there's people that are mad at me. Oh, and I can't get my email, and I got to be on a Zoom call in 20 minutes. Yeah. So there's still folks that don't update their stuff because we may be users in the security space that are not traditional and tend to do those updates more frequently. Okay. So this potentially turns into a recipe for success if we're thinking SBOMs for evil. All right. So now when we start looking at a software bill of material for something like OpenWrt, we're really given a ton of data. How do we get an SBOM for OpenWrt? Unfortunately, they don't provide them publicly. I specifically haven't asked them for one because I kind of wanted to illustrate a point here. But they do have GitHub repos. GitHub can generate software bill of materials from your code repositories, but the admins of those repositories have to initiate that. I can't just go to some random GitHub repo and generate it, but I can fork it and then generate it for my own. Okay, so there's one way to get SBOMs for some of this type of stuff. Okay, and then we need to do some of that enhancement. So we need to check CVE, CPEs, and maybe even some threat intelligence. This potentially takes a little bit of time. We could use something like dependency track for finding the CVEs and the CPEs, but the threat intelligence, finding those exploits is where a lot of the time comes in. Admittedly, I cheated. Okay, I work for a company that creates SBOMs and does binary analysis. So I took an OpenWrt firmware and I ran it through our product. Okay, so I did the hard work in a very short period of time. Okay. And in this case, our analysis had that there were just over 1,500 individual findings for this OpenWrt image that I had downloaded. Okay. And you look at that 1,500 things, Larry, that's insane. Well, if you think about it both from the good and the evil perspective, look at the criticals and the highs and then maybe start moving into the mediums a little bit. Okay, so at that, there were 10 critical and 38 highs. That's where I'm going to focus my effort as an adversary and see what I might be able to exploit out of there. Okay, so those are the ones that I care about on my initial pass. And you can bet if they're critical or high that there is some CVEs associated with it. Okay, so a little hard to see on the bottom right on the screenshot here, but some component matching, something like dependency track. Again, I cheated within our platform at finite state. CPEs for individual components recognized within OpenWrt do have some CVEs associated with them in those 10 to 38 items. Okay. So now we potentially have some items for us to attack, or on the converse, fix, right? All right, so let's dig into some of these CVEs. And this is the joke that I probably have to explain to a number of you, because specifically looking at the package here is for Luci, L-U-C-I, which is the web-based interface, okay? And yes, I did not watch I Love Lucy when it was on originally. I'm not that old, but I did watch it in syndication. So yeah, you may be familiar with Desi Arnaz saying, Lucy, you've got some splaining to do. Okay, so the Lucy package, the web-based front end, we probably have some explaining to do here because there's some vulnerabilities here. Okay. Specifically to note, one of the CVEs that matched was CVE 2019-12-272, which ironically, I was hoping that our platform would find that there was some threat intelligence tied to it. There wasn't. That's okay, because if we think about that, our product is a paid service and software is a platform and so forth. But this is where you'd be potentially on the open source side with something like dependency track. You've got to do the digging. You've got to figure out what that threat intelligence looked like. So, hey, this is a perfect case because now I can't cheat anymore. I've got to go dig for that threat intelligence. Okay. So if Lucy has some vulnerabilities, 2019, 12-272, what's our attack targets look like? So I went to Shodan and I searched for Lucy, and there are just over 61,000 hosts connected to the internet directly that Shodan knows about that returned the string somewhere Lucy in their web-based interface. 61,000 possible targets. Now, are they running the vulnerable version of Lucy? We don't know. I didn't go into that deep of analysis. To make matters even worse, there's the CVE says specifically for vulnerabilities in Lucy version 0.10. OpenWrt, when they install their packages, their versioning is completely different. They do like git nightly pulls. So versions on OpenWrt are git dash 4 digits dash a string from the git check-in. So they don't match any of the CVEs. That was a fun discovery. My job next week is to go to NVD and update all the CPEs at NVD. So for all of the versions for OpenWrt. Yeah, like, we've taken something and we've potentially turned it for evil, but why don't we go back and make everybody else better at the same time, right? So that's one of my jobs next week. Okay. So 61,000 possible targets hanging out there on the internet. Okay. So I didn't have any linked threat intelligence. Any of the threat intelligence feeds that our product knows about didn't have any exploit code of proof of concept, and it didn't have any indicators that that this would be something that we should focus on. And it wasn't a problem with our product, it was that the threat intelligence feeds didn't know about it either. And I was on the podcast, the Paul Security Weekly podcast about 2 weeks ago, and I was mentioning that this was a source of my frustration in that trying to put together some of this demo and some of this case study was that, yeah, we've got some exploits, but none of the threat intelligence feeds knew about it. It was a manual process for me to go find some of this stuff. But in this case, the power of community was really huge. I had talked about it on the podcast, and one of the folks at one of our threat intelligence feed vendors said, "Hey, I listened to your podcast, and you mentioned that there was some proof of concept code with something Chinese based, and it wasn't in some of the threat intelligence feeds. You're right, it wasn't in ours. Can you share with some of that stuff? And we want to populate the feeds and make sure that some of those feeds are populated." Absolutely. Guess what? Their threat intelligence feeds have been updated as of Tuesday and includes this type of stuff. I initially thought that part of the reason why they may have missed some of the proof of concept code is because of the differences in character set, UTF-8, and what they were searching and so forth. No, it turns out they just never had this particular group on their radar for releasing some of this type of stuff. So Google Translate was my friend on this one. Yeah, I don't know what I'd do without it. Okay, so don't learn Russian. Yeah, Matt said don't learn Russian. Yeah, just use Google Translate. Yeah. So in this particular piece of threat intelligence for CVE 2019-12-272, there was some proof of concept code attached to it, and they even had a virtual machine that you could download that was vulnerable to this proof of concept attack. Cool. But do you think I want to download a virtual machine provided by China? Yes. Yes. No, I went and actually found a new image from OpenWrt, put it in a virtual machine, and did it that way. That way, it's right from OpenWrt and can prove that is the case. Okay, so I did some playing with the CVE. And did some fun stuff with the command injection for CVE 2019-12-272. And just in case the demo didn't work, I captured some screenshots of the really lame stuff, right? Like a directory listing. Yep, there's a directory listing there. And as part of the remote code execution, it writes data, to output.txt in the web server directory, and then spits that back to you. So that's what this output.txt is. It allows us to create files. So I did Unix touch command to touch a file called pwned, and it creates a 0-byte file on the file system and another directory listing pwned. Okay. Well, that's cool, and I've got time for a demo. So let's see if we can make this work. Okay. Readable. Okay? Great. All right, so we'll start on the bottom here. Start a netcat listener on my local system on port 6660. Okay? And I have an OpenWrt image running over here on a virtual machine of the vulnerable version. It's, Chaos Calmer 1505, so it's a considerably old version of OpenWrt, and it has been patched quite some time ago. And it captured. So we've got the CVE Python from the Chinese disclosure there to interact with the wireless status web page to do command injection. The IP of the virtual machine is 172.16.123.129. We needed to provide it some credential information, including a username. And what's the default username on OpenWrt? Root. Yeah, it's well known that the default username is root. It's all in all their documentation, so that was pretty easy. And then we tell it what command we want to run. Well, great, we did some directory listings, but wouldn't it be cool if we could get a shell? Yeah, hey, how about that? So, never mind the man behind the mirrors. The demo worked a week ago. And I spent like 6 hours getting all of the redirection with the make FIFO and you name it, piping it to the limited version of netcat that's within BusyBox on OpenWrt. And guess what? Nothing. It worked. I swear it worked. So I could have just said, "Hey, never mind the man behind the curtain, smoke and mirrors, and look, we got a shell prompt," and then just walked away. Right? Yeah. Right. But no, I'm not going to do that. I'm going to say it was. I'm so close. It's so close. I spent 4 hours yesterday trying to fix it again, and decided to come hang out with people instead. So it's close. It did work. I don't know why it's not working now. I copied all my commands and I saved them in a text file, and they're in all my command history. And yeah. Alan made his sacrifices to the demo gods, right? In the opposite direction, right? Yeah. I could have written it in Perl and I'd probably have been fine. Touche. You're probably correct, right? But that would have required more than 4 hours, right? And you'd never be able to read it. Okay. So, but yeah, the irony here is that I can type into that netcat listener, and then the next time I run the exploit, it gives me the prompt and all of the commands that I typed in. Because it's taking that from output.txt. Like, I'm so close. I tried redirections for standard error, standard input, standard output to files, and never mind the man behind the curtain, right? It works mostly. But so I tried to go for the this is crazy remote shell, and I had it working, and now it doesn't. But the point being here is we're really close, and there's still a whole lot of things that we can do through that manipulation. And I tried to just go to the nth degree. I went from ls to shell, right? And it didn't really take a lot of steps in between. And there's still a lot of things that we could do on that device to potentially use that device within that organization for bad. Or as a penetration tester, maybe good. Okay, so does it work? Yes. Okay. Midjourney actually got some of the text somewhat right on this one. This is the slide that when I initially had the book for when we start talking about SBOMs for evil, it's a little bit of a choose your own adventure. The kerning is really bad on this, like the Y is too far away, and most of the time it was like SBMs and really bad on text. So to wrap us up, let's talk a little bit about that adventure using software bill of materials for evil. Okay. What we really get out of using software bill of materials for evil is a couple of fold. One, it's really up to us to improve by taking that data that a software bill of material that is provided or that we generate and be better. And we'll talk about, Larry, this is an evil talk, right? Yes, it is. But it's taking that mentality of being evil for being better. This is why we have this concept of a penetration test. Like, we hire people to come into our organization and think like an attacker, think like an adversary, and be evil so that they can tell us what they did so we can fix it. Hey, let's do the same thing for software bill of materials. Let's take that evil tack so that you can provide that to your in-house teams and they can get a better understanding of what's in their environment. Okay. Software bill of materials are not going to go away. We saw some stuff with the EU cybersecurity, with Omnibus 2023. And we are quickly getting to a point where it may be some requirements for use and or the law for you to submit software bill of materials into organizations that are using your product. Okay. So great. Once we've got a software bill of material, that software inventory is fantastic, but making informed decisions around that inventory is even better. And this is where the enrichment and the enhancement comes in for those CVEs. Okay. So doing that enrichment enhancements can give us some better decisions to make about how we can secure our environments through being evil, over than what a traditional base software bill of materials without that enhancement or enrichment can provide. I think one of the biggest things is that if, as an organization, that if you're not using software bill of materials to improve your development lifecycle, to improve your security posture, or even part of doing your pen test data gathering, like that was some of my favorite things to do on a pen test was, hey, Larry, you're doing a pen test in a week. Great. I've got a week to gather data to find a way into this organization before I even start sending a packet. Okay. Take that inside to your teams and think like an adversary and use all of those same resources. And we, for the most part, as an industry, do not share SBOMs publicly currently, but you can bet if you share it with a bunch of folks, it's going to end up out there on the internet at some point. Maybe you didn't want it to be there, but it's a good possibility that it's going to be there. So assume that that data is going to be something that your adversary can come up with as well. So if you are not using your software bill of materials to think evil and you're not using it to improve your process, these are huge missed opportunities for you to improve your security posture, whether you're a supplier or you're the end user, the consumer of some of these devices. Yeah, use that advantage. Use this concept of a software bill of materials for evil to do good things. Okay, take it into your environment. Look at what's in your software ingredients list. Look in your SBOM. Enhance it, enrich it. Find vulnerability data and go, we need to fix this. Great. Can you actually get proof of concept code? Can you write proof of concept code against your own devices? And update your stuff and update your software bill of materials so that you can have some better assurance that the binaries and the software that you are providing or that your customers are using is the most secure that you can make it. By putting on that evil hat, do good things. Okay. And then ultimately, once the industry around software bill of materials starts to get a little bit more maturity to it, take that good work that you're doing about all of that analysis and start getting vexed, right? Hey, we did the analysis. We found that the component that we're using has been noted as being vulnerable through a CVE. There's proof of concept code here, but we never call those functions in the portion of that code that we use, so we are not currently vulnerable, and share that as part of that data. Well, that's great. Use that for the folks that you provide those to, and well, now all of those adversaries are going to look at the same thing and go, well, I'm not going to waste my time with this, and maybe we'll move on to something else. Okay, at least what we can hope. Okay, because if you don't start using this data to your benefit, your adversaries will, and that's evil. Okay. All right. So ultimately, it's not just the data, it's about how you choose to use it. And I've built a lot of my career on thinking about strange ways and how people can use data. I got a chance to I want to say spend some time virtually with Adam Savage many years ago, because we found that some of his pictures that he posted on Twitter were geolocated, had latitude and longitude information. And I knew where Adam Savage lived. And then we tweeted about it. We didn't tell everybody where he lived, but we went through that whole process. And many years later, I got to be in a New York Times article with Adam about this whole process, and thinking about how folks use data. And for me, that was really about using software bill of materials for evil that maybe folks aren't thinking about how to improve their process and being better about it. But you can bet your adversaries are thinking about how they can figure out what's in your stuff to use it for their benefit. So let's use it for our benefit too. Okay. Thinking about how we can use the data. Okay. SBOMs aren't going to fix everything for us. It's about how we choose to interpret, how we choose to enhance and enrich it, and then what we do at the end of that with that data. We can use that to write our own story. We can choose our own adventure with it. Okay. The SBOMs need that enrichment to be valuable for that attack path. Okay. And not only that, for the attack path, but help our blue teams figure out what that attack path may be so they can be better about it as well. Okay. And ultimately, it's kind of the point was that with enough data, there's potential for our adversaries to start building that attack path using the available data between CVEs, CPEs, vulnerability disclosures, threat intelligence, based on the software ingredients of your product. So please do your due diligence. Okay. So I've got stickers. Okay, but out of deference for our next speaker, I'll go hold up right out front, out by Reg's desk, and I've got SBOMs for evil and SBOMs for good stickers. So happy to chat, but want to make sure that our next speaker has enough time. But I've got a couple of minutes for questions, it looks like. So questions, trolls. Yes, sir. So is there any distinction between SBOM and BOM? By definition, SBOM is software bill of materials. BOM is bill of materials. And there's probably a little bit of wishy-washy to that. Traditionally, when I hear BOM or bill of materials, I'm thinking more hardware bill of materials. And there's now even an HBOM, hardware bill of materials, and in fact the FDA was actually looking to require some of those, and they've backed off a little bit on that. What's an HBOM? It's the traditional BOM you might see when you're building some electronics project type of thing, best case. But we're starting to see a lot of these sort of BOMs come together under multiple umbrellas. I'm just waiting for the F-bomb, right? Okay. The X-bomb, yeah. Okay. Yes, sir.
I have a couple questions, actually. One is, where do you see the transparency in SBOMs going or plugging into things like the SEC starting to require vulnerability disclosures? Do you think that we're going to see larger requirements for SBOM transparency? Like, where is that heading?
Right. So where do you see the need for SBOMs when we start talking about vulnerability disclosure with an SEC requiring some of this type of stuff? And are there some ties to that? I want to make sure I'm repeating some of the questions for posterity and so forth.
Or it's going to require SBOMs when a vulnerability is disclosed.
Yes. So yes.
On the docket right now.
On the docket to have SBOMs when vulnerabilities are disclosed. For which was that?
It's a FAR case.
Okay.
They're
For
saying
a FAR
that,
case?
yeah, if a vulnerability is disclosed, they can request an SBOM from the product. You should have one.
Okay, awesome. So yeah, if they request that you have an SBOM for a product, you should have it. I personally would love to see further adoption of SBOMs and tying some of these types of things together. And it's not just because I work for a company that does SBOMs and I get a paycheck because people like SBOMs, but yes, it is. So I will fully admit that. Like, yeah, I get paid to help develop SBOMs and think critically about how folks can use that. But I think having that data is in everyone's best interest. And sharing publicly, that one really becomes tough. Because if you start sharing SBOMs publicly, you've done just that. You've potentially given all the adversaries the ability to do their enrichment to come up with these paths. So fix it before they get to it. So I think we're probably going to get to a point where the software bill of materials are shared a lot more publicly. And if they're not being shared publicly, they're going to get there anyways. There's just going to be collections of folks that, hey, you can have it via email, and we didn't tell you what you could and couldn't do with it, so they put it on a GitHub repository somewhere. Okay. And you had was that one question, or you had another one?
I did have one more question.
Awesome. And then I'll get you.
So when we're thinking about mitigating time of check, time of use vulnerabilities, building pipelines, right? We've got SBOM generating tools in CI, CD. What kind of work have you seen in the space through, I don't know, open policy agents or whatever, when things are actually deployed that are going back and verifying that like what's being deployed is actually matching the SBOM?
That's a great question. Unfortunately, I haven't sort of been on that side of the house to see some of that, but I do know that there's a lot of big customers that do that type of, big organizations that do that type of stuff. I did a webcast last year with Microsoft, and my understanding is that they do similar types of things, and they are doing that type of stuff. And at what scale, I'm not sure. But they generate somewhere in the order of millions of SBOMs a year as part of their CI/CD pipeline. So yeah, that might be a hard problem to crack depending on the size of your organization. Okay. We had one down front, right? And then if we have time, I think we will.
It sounds to me like there might be a giant business case need, which is the sense of when I'm on Amazon.com and I'm looking at a home security camera,
Mm-hmm.
I want like a QR code or something that I can scan that'll tell me the most recent updated version of this thing is okay or not okay or whatever. And also, these are the ones I have installed in my house. I've got 8 security cameras. 2 of them are first generation, 6 of them are second generation, whatever.
Yep.
When they go and all of a sudden have a vulnerability, go log into the app and click that update button. And I don't need to know what's in the bill of materials to know that.
Yep.
I just need to know to go and do it. And it sounds like there's a giant hole there where somebody who knows that information could put up a website that gives me that information.
So to distill the question, comment, great stuff. Yep. This seems like a great opportunity for folks to correlate that data. So when I go to Amazon and I buy this IoT product, I can get a software bill of materials, and folks can say, yeah, no, these vulnerabilities and these things, and do it later. And you want a job? Yeah, seriously, that's where we need to start seeing some of the industry go, and I think we're already starting to approach that, but we're struggling a little bit to get older. And I'm being told I've got 1 minute left, and I want to make sure our next speaker has plenty of time to get up here. But if you want to grab me in the hallway, happy to chat. Yeah, follow up. Okay, awesome. Thanks everybody, and enjoy the rest of your con, and be safe, and go get some SBOMs.